I've been trying to get a team together to look at this, okay? Oh, things not even working. That's okay. It'll work once I do this. Here. But it will. Yep. So there's our lab, right? We just saw that. And that's what it gives us, right? We do these little things. Don't go to sleep. Make it a little easier to see. I challenge all our students with this as well. I mean, that's kind of what the scanner prints out. I think it's its greatest asset and worst detriment. Because, you know, I've started looking at the classifications of bodies. How are they classified? Because I don't think that manufacturers or brands really know who they're fitting. Y'all probably do, because you do you do some custom stuff, but you know, we're using data that's old and using data that's extracted different ways, but there's different ways things actually come out. This really doesn't matter so much. That this is kind of what I worked on, is taking the raw data, those raw RBD files, and seeing if there's a computer algorithm that could cluster them. Not measurements. I don't want to see all the size 16 necks or all the size, 36 waist or whatever. I want to see this overall thing. Can it tell me what these clusters are? Can it say, you're trying to fit this? Well, out of the data that I had, we started off actually and we had 10 males and 10 females and thought, you know what? If this thing can't look at a male and a female and say, these are different, and put them in two clusters, then this is useless. Yes?
Well, that makes me think of something. Right now, the trends of having like androgyny in fits. I just want to know if you'll hit on that, like maybe not in a second, I just don't want to forget.
Well, as a matter of fact, in our 10 and 10 that we scanned when I was at Auburn, there was one piece of data that was male that it classified as female. And we didn't even look at these things. We didn't even look at this. All we did use those for was to verify. All we did was take the files and let the computer look at them. And it broke them up into 11 and 9. It's like, uh-oh, something's wrong. Once we actually pulled the scan up, it was a male that had a lot of female attributes of body form, visually. So it was right. It just said this looks more like a female.
And he might have fit female clothing.
It probably did. Yeah.
I mean, I know I buy men's clothing. Sometimes I'm like, it fits me better
That's
than
right.
female fit.
So it told me a couple of things. That yes, it can tell the difference, but also it can look at little subtle differences as to how things fit. Well, so I did that. Here's where I get into. This is where I lose people sometimes, but I hope I don't lose y'all. Size. I had a professor at Auburn when I was working on this. I kept saying, I don't know what we need to be looking at body shape, not size. We need to be looking at the shape. And she looked at me and went, she wasn't even related to my research.
Who are you? I went to Auburn. Who are you? Who was she? By any chance?
I had actually my two lead researchers. Well, Pam Ulrich is still there.
Okay, yeah.
Pam's still there, and Linda Jo Cannell.
Okay,
she
yeah, that's good,
she
yeah.
retired.
Yeah.
But Vina Chattaraman.
Okay. She
You know
was,
Vina?
Yeah, she had just started
She's-
when I started school there.
She's
so.
kind of art.
Okay.
She was the art.
Yeah. Awesome.
She brought that perspective into it. She and I had coffee one day. See, I was the old graduate student. I was 48 years old when I went to do my PhD.
Yeah.
So
I don't know if they'll remember me, but I definitely remember all of them.
if
so, yeah.
Dr. Bien, Sangan Bien, and Weesuk Kwan. Now,
Okay,
you know Weiss.
yeah.
You know Weiss.
Yeah.
She's really good too.
Yeah.
So I bounced this stuff off all of them.
Yeah.
And Vina Chattaraman looked at me and she said, "You're thinking about it all wrong. You're trying to categorize shape. You're not. Our bodies are not shapes, they're forms. It's a form. Think form. Don't think size. Don't think shape. Don't think form." Because there's a lot of research. There's tons of research out there with this. With size, there's some shape. Like, hourglass, pear, apple,
Basically, the way
triangle,
it
inverted
looks.
triangle. Huh?
The way it would block light.
That's
just it, but then.
well, and they basically had tons of research where they looked at these things, said this looks like a pear, this looks like a whatever. Look, shape's two-dimensional. We're not fitting shapes. We're fitting three-dimensional objects. Volume, I don't know. And this is where I stop. It's hard for me to go beyond this, and I'm trying to convince people. Because we all want to take it, we all want to take these three-dimensional objects and measure, right? That's cool, oh, it's cool, it extracts all those measurements so quick. That's its greatest asset and greatest detriment. We can't get past that. We're using antiquated methods to describe the body. Anytime you take data and change the dimensionality of it, you lose value. You go ask all the data science people, they'll tell you. If you've got three-dimensional data and you convert it to 1D, you're losing tons of value. Doesn't matter if it's bodies or what, you're just losing data value. So I started thinking, at one time, we really only had the tools to capture that. We got a measure tape, right? But I can promise you, if you put it around my neck and it's 16, and you put it around somebody else's neck that's 16, those two 16s aren't the same. They're different forms. Now, with 3D body scanning, we've got the ability to capture the form. There it is. So why are we pulling out one-dimensional measures? So here's what happens. It captures this 3D in that RBD file. All it is, you can pull it into an Excel spreadsheet. All it is 1 million XYZ data points. That describes every one of these parts. And then we can do cool stuff with it. We can slice the body. You know, I can tell you exactly what this is and what this is. We can slice it in 1 inch increments. That's all well and fine. But that's what it gives you. It gives you 1 million, it's amazing. It gives you 1 million data points, XYZ, along these axes, right? So why, if we've got 3D data, why are we extracting one-dimensional? I think we're wasting time taking this to flat pattern. That's what I think. I think that's completely ineffective.
Yeah.
I'll use a couple
We
words.
need to go forwards.
Yeah, it's ineffective. It's really efficient. We got really, really efficient at doing that, but it's not effective. We have this, and this is where I lose people most of the time. We have that, and we can get that for every single body in the world if we scan them. But we don't know what it means, right? We know what this means. 16 inches,
Yeah.
35 inches. We know what that means.
We're not caught up to the form yet.
Right.
Spreaders, spreading fabric flat and cut it out flat.
Here it is right here. It's form. Here's what the industry's doing. This is what I think. Here's what the industry's doing. I made up this little thing. I haven't published it yet. That's what I was gonna go show over at, in Switzerland in 2020, but.
We can all talk next week.
Yeah, do what?
We can all talk next week.
Oh, yeah, cool. Let's go.
We can.
Well, here we go. We're starting out with a 3D human body. This is the industry. This is what we do, right? Here's a finished t-shirt, right? Finished garment. 3D. Well, what we do is, there's several different ways we measure that. Somatology, you got build, shape, size. Then we got flat patterns, which are 2D, which I have to argue. I always argue with the fabric people. They'll say that these fabrics, that's what all the books say, fabrics are 2D. Fabrics they're actually three-dimensional things, but for our purposes, they're 2D, you know, they're flat. So what we do is we take all these measurements and convert it. We take 1D, we take a 3D, convert it to 1D, and then go to flat pattern, which is 2D, and then use fabrics, which are 2D, and then we use parts, panels, and pieces, or, you know, shaping methodology, seams, darts, pleats, whatever, stretch fabrics, dart equivalents, whatever you want to call all that stuff. We go 3D, 1D, 2D, 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 these methods to make this 3D again. How many times we change dimensions on it? No wonder stuff don't fit, you know? Here's what we need to be doing. We need to just do the body scan and figure out through additive manufacturing how to manufacture things into that shirt. If we can 3D print a body, we can 3D print a shirt, period, end the conversation. All you gotta do is program in a little ease here and there, you know, and talk to the polymer people, because you know what they're printing. You know what they're printing over at the makerspace here, those 3D printers, it's polyester and nylon, and those are the polymers they're using.
What about salvage denim, Rick? Come
Well,
on.
you gotta have the
Can't throw
purist.
that out.
No, we're not throwing salvage denim out. And you know, half our kids don't know what salvage denim is.
What about some of the like knitting machines now that
They can do 3D.
3D?
They have the seamless knitting machines that can take that, but what, how are they sizing them?
Small, medium, right?
They're using, right.
Well, and they're stretchy, so they don't really have to fit.
Right.
If you really had to
So you
get rigid.
you can use in fitting, you know, some stretch fabrics, which make it even better, right? That's good. We can move in these things, but I just think that we're, you see what I'm talking about now? That the data that's sitting there in that RBD file is so much more valuable than the measurements coming out. So much more valuable. But in the interim, we got a great tool to help y'all if you're doing 3D design and browseware and stuff like that we can pull this stuff and get the measurements real quick, usually, and experiment with it, and experiment with using some of those things. But that's what I wanted to talk about. Anytime I get I do this. I mean, that's what I would do at the thing in Switzerland. I say collaboration. That's what it's going to take. I don't know how to do this. Let me tell you something. If I knew how to do that, I wouldn't be doing this. Right? I wouldn't. If I knew how to do that, boy. But we got to look at what the apparel industry is going to be in. And so I want you to think about this. If I've got data science people now working on, here on campus, there's some new techniques out there. It took a bunch of number crunching to take those million data points. You had to normalize the data, then you had to pull it down to stuff I don't even have any idea of what it is. But now, it doesn't take such strong computing power. They can take a demographic of, I don't know, males 25 to 35, whatever demographic. Y'all know your demographic on certain things. I guarantee you know your demographic on, what you call it? The Forestry Service. It's one of your big clients, right? You know the demographic there, probably.
No.
You don't?
No, and that's what's really, so I've talked to you a little bit, I think, about our virtual fit tool that we've been working
Yeah.
with, and we are able to use a phone for that.
Mhm.
And so part of what I'm interested in is so I'd like for us to get our body scanned, whoever's willing to do that today, because then I want to
Yeah.
compare that to our virtual fit tool and see how accurate it is.
Yeah.
But that's what I'm really excited about when we launch this virtual fit tool into our managed program specifically, because does a forestry body look different than a
Yep.
mechanic?
Yep.
And does a New York City Transit worker's body look different if they're working in the FR division or
Yep.
their electrical division versus a truck driver? You would
Yep.
assume so.
They do.
So then, as we're building our products, another thing that I talked to Amy this morning, I was supposed to tell you that in the car,
Mhm.
but looking at it on a static body versus looking at it on a body in motion,
Yep.
and all of those things. So not only getting the static, hands out scan, but version 5.0. What does that body look like squatted? What does
Yeah.
that body look like bending over?
What do they
What
have
does
to
that
do?
girth do? And what does the girth on a 60, waistband pant do versus 28?
Right.
All of those things that follow the form. And again, your body could be shaped this way as a waist, it could be shaped this way as your waist.
Right.
And so that garment is not gonna fit the body the same way.
Nope.
And, I'm a huge additive designer.
Yeah.
Like I crochet like that and knit and just the form, my thesis is around the form. And so taking all that into consideration, unless you're seaming up a bunch of panels in flat fabric, you're never gonna get that form, and you're never gonna get that contour of what the body is. And so we've done some really cool things with mimics, and that is incorporating stretch with a woven fabric. But yeah, all this is super intriguing, and I think you've got the right minds in this room to glint and glean some more of that future forward thinking. And we've just been doing it the same way for so long.
Yeah, that's the thing. We've got to measure with our measuring tapes, right? But you really don't. I mean,
And that's what the beauty with the ADA files is.
yeah.
Because then you're looking at those bodies, then you can start categorizing, like you were talking about. You can categorize those bodies. So no longer are you categorizing male to female, but can we look at all males in this occupation?
Yeah.
And that is power.
That's power. And that's what I was telling you. I've got folks in data science here that, the guy showed me a paper, and it was like in January of this year, that somebody in somewhere came up with a new algorithm that makes it so much easier for them. I don't know how to describe it. He gave me the paper, and I'm looking at it, it's like, I have no idea what these people are talking about, but I've just given this guy access to all of our files. And what we wanna do is take a demographic, transportation worker. You can that specific, or you can be as general as the general population. Usually brands know who their demographic is. You just give them the demographic, tell them to go in and pull all those files that correspond to that demographic, and what they can do is actually throw up here how many different, significantly different clusters that there are. You don't have to look at them and say this one and this one and this one and this one. Computer looks at them and goes, here's a cluster that look alike, here's a cluster that look alike, here's a cluster that look alike, here's a cluster that look alike. And you can set different parameters. You can't say, you don't want to necessarily say, give me 5 clusters, but you just say, how many clusters do you see? But then you can start narrowing the clusters down. You can start refining it and saying, you know what, this outlier right here, maybe this one's over in this area. But then they have the ability to morph all the ones in that cluster into a representative body type, into one somatotype that represents this with such and such error. They got all kinds of data. So they're working on that right now to cluster these things.
Have you seen body.me? Body.me, M-E. It's a scanning system, and so they've identified these clusters, and then when you scan yourself, they match you to a digital twin.
Yes.
That's different than what we're doing. We're
Right.
not matching your body to a digital twin, we're matching your body to your body.
Yep.
But it sounds like.
And what they're doing is called supervised clustering. They're saying, here's where does this body fit most in this, right?
Yeah.
Where does it fit amongst these 5 or 6? What we're doing here is just unsupervised. It's taking a scan of all the FedEx drivers. I don't know how you collect those scans. If you get a representative sampling at FedEx or whatever, but you collect those scans, and then you can get a demographic. Then you can start saying, hey, of these people that are drivers at FedEx, they look like this, and their waist is like this and not like this, or it clusters. We're not talking about clustering just visually 2D shape. We're talking about the whole form cluster. And then I asked Josh I said, so you can take these, out of these 500, these 75 that are in this cluster, and morph them into a representative, and show me a person that is not like anybody in the group, but it's like everybody in the group.
That
said, yeah.
reminds me of a movie. There's
I
a
know, this is
movie,
crazy.
Gattaca, it's about that.
Mhm.
That based on your attributes and your
Mhm.
body shape and your age, you got assigned that job.
Hey, but you know what that does? That goes, the seminal work that's done in body form was a guy named, Sheldon is his last name. Sheldon, he was at Harvard, I think. They destroyed all of his data now because he took naked pictures of people. But what his thing was, this particular body shape has high criminal activity. That was what his research was.
No, he didn't.
Yes, he did. He was saying certain facial features and certain body features tended to be more criminal. So, I mean, but that's the seminal research that was done in this stuff, in clustering bodies.
Well, it makes me think my father-in-law's a funeral director, and if people would sign a waiver, I guess, when you die, like, they measure, they weigh your organs and everything.
Yeah.
Maybe they could do your body type, and
Yeah.
then there'll be a
As people die.
database of, I mean, your body's a little different, I guess,
Yeah.
depending on when they get
you
you,
lose
but
mass when you pass. I
we
think.
get some info from it.
Yeah.
It's a little less, somebody might be more willing, yeah, sure, I'm gonna
Right.
go ahead and, I'll take on that.
Well, some people donate their bodies for research already.
Yeah, they do.
Mhm.
Mhm.
Yeah.
That's something. But that's kind of what I've been thinking. I don't know. I'm willing to help move forward. Anything y'all want to. If you need data analyzed, I can talk to Josh Allen, not Josh Allen, he's football. Josh Phillips about doing some high. Oh, those guys start drooling when if I say, I've got about 500 scans, and each one has close to 1 million data points. They're like, oh, you got data, that's what they want. They don't care what it is. They just want to see it. They just want to analyze it and see what it tells us. And that's what those clusters become, unsupervised clustering. Because, one particular demographic is different than, I always tell our students, if you want to make a lot of money, design for females 45 to 70 and children. Because females 45 to 70 are stylish, they buy clothes, that demographic's got money. And guess what? For the kids, mom and daddy's broke, but grandma's buying. 45 to 70, grandma's got money. How many times I guarantee you, if you need something, you call, I guarantee you, grandma's always got some money, don't she?
Yes.
To bail you out.
Yes.
Grandma's always got something to help.
Slip it in your hand on the way out the door.
Uh-huh, that's right.
But
Turn
that
high.
makes me think,
Yeah.
like, the body scanning, how young does it go? Like, how do you get clusters of all ages that young?
That's the hard part is, how do you collect the
Or you
data?
have the pediatrician.
There's a
that's
bunch
safe
of,
place.
there's a bunch of data already out there. That Size USA, they have Size USA, Size Asia, Size Africa, Size Europe, or something like that.
What
There's-
about at the airports? Do they, when you get scanned, do they collect your information?
I don't know. They're doing scans.
Yeah.
They're doing scans, so.
They're taking your data somewhere.
Mhm.
Interesting.
That's how,
But we're
that,
not, oh, I
that's
guess
how,
it could get it through the clothes, yeah.
that's how all of our sizing data came about, was the Air Force study. If you go back to look at a lot of the data that's out there right now on sizes, it came from the Air Force from like 1940 to 1960, 1970. Do you think those bodies in the 40s through the 70s are the same as we are now? No. Yeah, but they had a captive audience, and when they're coming in measuring for their clothes, that's another good a good resource to. I don't know if you could partner. I don't know how they feel about that, but that's a huge apparel. Anywhere from tuxedo dress uniforms and all the way to tactical stuff, is the military. Because they are doing research, and I don't know how much of it they would share.
Isn't
but-
that where standardized men's pants came from, was when they were like measuring soldiers to fight like the Civil War?
Civil War is when
Yeah.
that's where it came from.
That standardized system.
That was
Yeah.
the first, make a whole bunch of pants and here.
Yeah.
You know, you put this on. It was even before they had patterns and stuff, but you had to, somebody at home had to make them.
Right. That's why they had a lot of adjusting
Mhm.
seams and buckles and.
And then, you know, Levi's one of your competitors or your former competitors, they started off with with the pants, plain pants, but the little cinch was back here, right? It was a little buckle back there. They still have it on some of them, but the little buckle, that's where you cinch them up a little bit, make them fit better. And put rivets on there, right? But that's the scanner. That's what,
Yeah.
so there's all kinds of things that we can do to help.
So as you're researching upgrading your scanner, Emily and I were just talking, so you can't upgrade the one that just goes through the clothes. So they don't have to get down to their certain requirements of.
There are scanners that you don't have to, that
That's
go
what we
through.
were asking.
I don't
Well,
think
just
so.
like at the airport, we assume maybe that version is like
There
all the way to the
is,
organs,
so that
but
people feel
how
less,
expensive.
I guess.
So Body Data has a radar scanner.
Mhm.
They have, I
Radar.
think, a physical scanner, and then they also have a handheld.
Mhm.
And because it's radar, it bounces off the skin, so it doesn't matter what you're wearing, unless you're wearing a water suit.
Okay.
That's an option.
Mhm.
I don't know if they have a full, I think they may have a full stand-in booth.
Yeah.
So, you know, that is something, but
I mean, that's something, let me tell you something there. Do you really need, I mean, I'd love to work with you on anything, but do you really need us? Probably not, it's cheap, those things, we bought that one, it was $15,000, which was cheap, because they were $50,000 when they, the reflective light ones, now they're cheap, I mean, I don't know what size stream, how much they charge, how much David Brunner and them charge for that, but I could put you in touch with David, and I'd probably come out as well to buy one, you know, cause they're not that expensive. And
it's on your phone now.
it's on the phone, yeah, but you gotta look at data accuracy and what, is it actually collecting a representative, point cloud? That's gonna be the biggest thing. Cause if you're just extracting measurements, you really don't need that detail of a point cloud, you just need certain things that need somebody with their hair pulled up so the hair don't get in the way, or no collar on so it doesn't pick up a collar or something. You know? But, I mean, there's tons of technology out there, and I would venture to say David, he would probably be a good contact for you, because David probably knows all the integration with Browseware and how all those things would come together, how they mesh up, because I would say size stream, probably pretty much on the cutting edge of most of the stuff that's going on right now. Guy's name is David Brunner, he's president of it. Dr. David Brunner. He's a nice guy.
Of course.
Huh?
Sir, of course.
Yeah, of course. But he's a good researcher. They're a good source. But we can scan whatever you need to scan and try to get the files in a format that you can, or you can get the RBD file and take it and play around with it. And try to convert it. If you can't, then we can get our folks around here to play around with it. Cause it's all software. That's all that is. How much does that computer's old anyway. How much does a computer cost? And how much are, huh? How much are Connect sensors? Not much.
Yeah.
You know, they don't cost much. It's all software, that's all it is. It's software.
I feel like you could charge more for the data of the demographic than for the technology.
Oh, sure.
Like just that somebody finally did that and had all the clusters to
And
sell to a company,
That's
that's the ticket.
And that's another thing that I mean, I can look a little closer. We looked at that at one time, but we were not that research intensive at that time. And I forgot how much you can buy parts and pieces of the Size USA data. They can,
There's also, I'm racking my brain, it's human technologies? There's another company that also sells human scans.
right,
It's human something technologies, I think. But that's where the company that we're working for gets a lot of their body data to be able to test against their algorithms. But yeah, all of those are out there, it's just, how do you get your algorithm?
that's where the, 30 years ago, talked to us and said, the world's awash in data. And the next big thing is not how fast it processes and all that stuff. The next big thing is sensors. This was 30 years ago. He said sensors are gonna get cheap. I remember temperature sensors on a production line where we were processing textile material at certain temperatures and things. Those things cost $5,000 for the sensor. Now you can get a temperature sensor. You can go to Walgreens, right? And get a thing put in your ear for $10. Sensors are cheap, and that's creating piles of data. And then he said the next most important people in the world are gonna be the people that can tell you what the data means. A lot of people got lots of data, but they don't know what it means. And that's our problem right now with these 3D body scans. We've got this point cloud, we don't know what it means. We know what 16 inches is. That's what we know. But we don't know what that point cloud is. And that, most people can't think past that. I had a hard time with it. Like, we don't know what that means. It's a point cloud. No. How do you describe it? How do you describe form? Well, with a bunch of measurements, right? With a bunch of 1D measurements? No. We gotta come up with something different. And I think clustering the forms are the first thing, is getting a representative and then deciding kind of what you're fitting. I think it's more a demographic. So, I mean, for you guys, it's probably, you could probably buy the data. And not even buy a scanner, just buy the data. Cause you don't, I mean, or utilize a service that you can say, we've got this type, this is what we're looking for.
But I don't
Specific
think the
thing.
data exists by occupation.
I don't think so either.
No one's drilling down that way, so we would have to own our own data.
Mm-hmm.
And I think we're 10 years away, but
Yeah,
in the
yeah.
next 5 years, we are gonna set the foundation for some really cool stuff when
Mhm.
it comes one like this.
I mean, if you've got good customers, good clients like FedEx that would allow you to scan and.
Well, I mean, you don't present it to them that way. You present it to them, how would you like to not have to get measured physically?
Right.
And be able to use this scan to measure yourself, and then we own the data at that point.
Right, that's right.
And get more accurate measurements.
You got more
'cause,
it's more accurate.
Like for made to measure stuff that we get, sometimes
Yeah.
I'm curious,
That
like,
would be a-
What
how
does that
did
body
you,
look like?
yeah, how did
it's a
you,
1D.
yeah.
Mm-hmm.
Like Leanne was talking about them, looking for innovations and things like that, you know, to bring it to them in that regard.
That's a good one. Could you reverse the process? Could you take all the measurements and construct a 3D model out of it?
Not a very detailed one. So,
Right.
I mean, some, yeah,
Or we could use them.
yeah.
Right. Could you reverse engineer it and go, well, I've got measurements, show me what the body looks like? Probably not accurate.
Right. Then there could be varieties,
Yeah,
like
there's definitely
5 or 6
varieties.
varieties at least, like,
Yep.
Long torso,
Yeah.
short torso.
Mm-hmm. Right.
Where
Because
your
somebody
weight
that,
is and where you wear your garment.
I can promise you, somebody that's 6 foot, I'm 6'2", I'm not the same 6'2" as a lot of people are. Some people.
Right.
Where's the waist? I heard a group at that 3D body scanning conference argue for like 2 hours on where do you measure waist? Where is your scanner measuring this waist? Is it at the top of the, do you have to there were scanners out there at one time that you had to actually palpate and touch and get that and put a dot there. And it looked at the dots, you know?
crazy.
Yeah. That was when it first started. Was that, but where do you measure these things? They fuss and fuss and fuss. And then you move to a different measurement and they fuss again, right?
And it's different on everybody.
It's different. Those things are different on everybody. And if you measure and you measure, you're gonna get 2 different measurements.
Right,
Different.
that's, yeah, human
You're gonna get 2 different ones. Just a little bit,
Yeah.
but y'all wanna scan? Y'all can scan. I got plenty of time. I got all afternoon. I can scan. we can scan and print and,
So we could all scan